What's up, guys? So, in this project, I created a neural network that's able to classify tweets as having a positive, negative, or neutral sentiment. And I worked with a data set of about 9,000 tweets that was provided by Crowdflower, which is a website that provides free data sets. And the tweets are mainly the public opinions of tech companies such as Apple and Google and their products, mostly the iPad. For my main approach of solving this problem, I use deep learning, which is the creation of neural networks that simulate neural networks in the human brain, also known as artificial intelligence. And I tried 4 different approaches. I started off with a feed-forward neural network, which is just like this neural network right here. Just the nodes fire into the next layer of nodes for all of the layers that the network has. So that was the first thing I tried, and it didn't really work out very well. So I used a LSTM, long short-term memory neural network. And what those do is it's able to the thing is able to use the sequence or order that the words are used in as context for the meaning of the words. I'm saying this because for this use case, it was words. It can also be used for time series data, anything where the order of things matters. So words in the human language or stock prices by the day, the order matters. And LSTMs are very useful for these situations. And ultimately, I used a bidirectional LSTM, which is able to take in the data in both directions. So it reads the tweets forwards and backwards. Of course, it doesn't actually read the tweets, it reads numerical representations of each word in the tweet. But because it is a computer, but that concept exists. Anyway, this is the architecture that I used for the neural network. I had 128 nodes in the first layer, and in the first layer is where I used this LSTM, bidirectional LSTM. All the other layers were just very basic, very simple layers. And I also created word embeddings. And what word embeddings are is like a dictionary for the computer. It can see how, through numerical representations, how similar each word is to all the other words in the vocabulary. In this case, I had a vocabulary of about 12,500 words throughout all the tweets. So it takes in those 12,500 words and feeds it into the bidirectional LSTM, which then feeds it into the further layers until it reaches the output layer. And how to make word embeddings. So when it comes to making word embeddings, you have 3 options. You can create your own. You can use this in the Keras library, which is probably one of the most popular deep learning frameworks. Although I'm sure you could do a very similar thing with PyTorch, which is another popular framework out there. I don't really know it, but I'm sure you could do it. And you can also use the GenSim library. The GenSim library, what I like about the GenSim library is that you can actually get to look at the word embeddings and see how similar each word is to each other, you can look at the words that are most similar to a word you select or the most different, aka least similar. And I like this because in the Keras model you can't really do that. You create it and then you blindly feed it into the neural network. However, the Keras word embeddings had yielded better results than using the GenSim library. And also, you can use a pre-trained word embedding model such as Glove. Glove is a very popular one. I'm sure there's other ones out there. And for setting parameters, I mainly advise using a grid search. And what a grid search does is a way of testing out several possible combinations of parameters. And this is a function I coded up that does that for me. Makes it really easy. And definitely, but just for some other guidelines, I would recommend testing between a ReLU and TAN-H as activation functions, and RMS prop and atom for optimizers. Atom and RMS are good because they prevent what's called getting stuck in a local minima. As you can see with this diagram represents backpropagation, which is how the neural network improves over time. And throughout the training, the neural network will learn the best weights that allow the error to be at its absolute minimum. However, sometimes it can get stuck in a lower down spot, but not the very bottom. This being a local minima, and RMS prop and atom are better at preventing it from getting stuck there. You can also use simple machine learning approaches without deep learning, and I'm sure they could work just as well, especially when I'm only working with about 9,000 tweets. If I was working with 50 or 100,000 tweets, it might be a different story. And I tried a very unique, very odd approach, and it did not really work very well, but that doesn't mean you can't make it work with machine learning. So what I did was I created these vectors that represent, basically each vector is 12,500 words, because there are 12,500 words in the vocabulary, and each tweet is represented as a vector, and there is a 1 for each word in the vocabulary that is used in that tweet, and a 0 for all the other ones. And this resulted in vectors having over 12,000 zeros and only about 20 to 30 ones. And this is called sparse data, when your data set is vastly composed of zeros. So what I did was I used PCA, stands for Principal Component Analysis. And I don't really know the inner workings of it, but it's a dimensionality reduction method, and I was able to use that to turn 12,500 number long vector into only being 300, having a length of 300. And I used those vectors, I fed those vectors into a gradient boosted random forest. Now, I would certainly recommend using a gradient boosted random forest if you're not going to use deep learning, because it is very powerful and very robust machine learning algorithm as compared to other methods such as support vector machines or logistic regression, which probably would not work as well with this much data and with text data as well. And for future works, like kind of like a good extension to this project could be maybe getting the model a little bit better, if I could, to have it label another data set of tweets with their sentiment and use that as a feature along with other features to create a polarity predictor. And I feel like this would be good because with social media, it's kind of polarized us as a society, and it would be good to have a way to predict be able to predict if a tweet is very polarized, and maybe if a tweet is past a certain threshold of polarity, it has to be censored. Just an idea. So anyway, that is the end of the presentation. Thanks for watching.